Good day, everyone. Today we are going to study continuous concreting operations using the slipform technique. Slipforming is an advanced construction method widely used for building tall concrete structures quickly and efficiently. Unlike conventional formwork, slipforms move continuously while concrete is being poured. This allows uninterrupted construction and saves both time and labor. In this lecture, we will learn about tall structures, the working principle of slipforms, their types, construction sequence, advantages, and applications in modern civil engineering projects. Before learning about slipforms, let us understand the classification of tall buildings. Buildings less than 15 meters are called low-rise buildings. Buildings between 15 and 100 meters are known as high-rise buildings. Structures with heights between 100 and 300 meters are called tall buildings. Buildings taller than 300 meters are called super tall buildings, while those exceeding 600 meters are known as mega tall buildings. The term skyscraper generally refers to buildings taller than 100 meters. Constructing these structures requires fast, safe, and efficient techniques like slipforming. Slipform construction was first introduced during the 20th century for constructing grain silos and storage towers. In this method, concrete is continuously poured into a moving formwork that slowly rises or moves forward while the concrete hardens. Since the formwork never stops, the structure is built without construction joints, producing a strong and nearly seamless concrete member. The concrete should be sufficiently workable for placing but must gain strength quickly so that it can support its own weight as the forms move. This technique is ideal for tall structures such as towers, silos, and core walls because it reduces construction time significantly. Slipform technology has many important applications in civil engineering. It is commonly used for constructing core walls of high-rise buildings, lift shafts, stair shafts, towers, chimneys, cooling towers, bridge piers, and storage silos. Horizontal slipforms are also used for constructing road curbs, drainage channels, safety barriers, and grade separators. Since the concrete is placed continuously, these structures become stronger and have fewer joints. Slipforming is especially suitable where long, vertical, or continuous concrete elements are required with high quality and faster construction. Slipforming is mainly classified into three types. The first is vertical slipforming, used for tall vertical structures such as chimneys, silos, lift cores, and bridge piers. The second is horizontal slipforming, used for continuous structures like road barriers, pavements, drainage channels, and curbs. The third is tapered slipforming, which is used when the diameter or wall thickness changes gradually, such as in cooling towers and chimneys. The choice of slipform depends on the shape, size, and type of structure being constructed. Let us now understand the construction sequence of vertical slipforming. First, hydraulic jacks and jack rods are installed. Next, the form panels are erected around the starter wall or pier. A working platform with safety handrails is then fixed. Reinforcement bars are placed inside the formwork, followed by continuous concrete pouring. Hydraulic jacks slowly lift the formwork upward, while fresh concrete is continuously added below. As the concrete gains enough strength, the forms keep moving upward without interruption. Workers continue placing reinforcement, embedded items, and concrete until the required height is reached. This continuous operation makes the construction faster and produces a strong, joint-free concrete structure. In vertical slipforming, the concrete usually begins to set within about 3 hours. The form depth is approximately 1.2 meters, and the average slipping speed is around 0.30 meters per hour. Hydraulic climbing jacks support the entire system and lift the formwork gradually. Each jack can carry about 3 tons and climbs 25 millimeters whenever the hydraulic pump is activated, usually every 5 minutes. The jacks move along steel jack rods that also become part of the reinforcement. Continuous monitoring of concrete quality, alignment, and lifting speed is essential to ensure safe and successful construction. This diagram illustrates the key components of the vertical slipforming system, including the concrete delivery, the lattice truss, the yoke, and the various working decks that move up the structure as the concrete sets. Horizontal slipforming uses a specially designed self-propelled machine equipped with molds and vibrators. A relatively stiff concrete mix is placed into the machine. As the machine moves forward slowly, vibration compacts the concrete, and the concrete emerging from the rear becomes self-supporting. The machine follows a guide wire to maintain the correct line and level throughout construction. This method is widely used for constructing road barriers, curbs, drainage channels, and pavements. The main advantages are faster construction, fewer construction joints, lower labor requirements, and economical operation for long, continuous projects. These images display horizontal slipforming machines in action, showing how they shape concrete for infrastructure projects like road barriers and curbs. Tapered slipforming is used for structures whose diameter or wall thickness changes continuously with height. Examples include chimneys, cooling towers, bridge piers, and other tapered concrete structures. In this method, specially designed overlapping form panels gradually change their position while moving upward, allowing the structure to achieve the required shape. Since both the geometry and formwork movement must be carefully controlled, tapered slip forming requires experienced engineers, skilled workers, and careful supervision. Although it is more complex, it provides excellent quality and faster construction for tapered concrete structures. In this lecture, we learn that slipform construction is a continuous concreting technique in which movable formwork allows uninterrupted concrete placement. We studied the classification of tall buildings, the working principle of slipforms, and their three types: vertical, horizontal, and tapered. We also discussed the construction sequence of vertical slipforming, the working of hydraulic jacks, and the advantages of horizontal slipforming. Finally, we explored the applications of slipforms in high-rise buildings, chimneys, cooling towers, bridge piers, silos, road barriers, and drainage channels. Overall, slipforming is a fast, economical, and efficient technique for constructing tall and continuous concrete structures.